Okay, so guys, today we're going to be looking at applying sketching to application problems, and um, yeah, so that's going to follow on from our previous lessons of using y equals mx plus c and sketching. Okay, so m is the gradient and c is the y-intercept. Okay, so if we recall the gradient, okay, this is going to be important, is the rate of change in y. Okay, so in this case we have a y. Now that might change today because we're doing application, so we might not have a y, we might have a different variable, but it's still the rate of the change with one variable with respect to another. And then the y-intercept, that was important because this was our starting position, okay, or our another term, initial position, okay. All right. Other key facts from the last couple of lessons were our x-intercepts as well. Okay, so when y equals 0. Okay, so three important bits of information there, and this one in particular, the rate of change. Okay, so we're looking for rate problems. All right, so now when we do application problems, okay, it's very important that we fully read the question, okay, underline keywords, identify what you do know, okay, and identify what the actual question is asking, okay. So sometimes it's clear, sometimes it's not so clear, but yeah, and of course we're going to be sketching the function, okay. So um, follow that process and it will help. Okay, so now reading the question here. The deal offered by BikeShare, a bicycle rental company, has a fixed charge of $20. Okay, so this part here is going to be important. $20 plus $5 per hour of use. Okay, now we want to write a rule, okay, for the total cost C dollars of renting a bike for T hours. Okay, so total cost is C. Okay, so then we're going to be sketching a graph of C, so that's our cost, versus T, number of hours, for 0 less than or equal to 10. So this is for between 0 and 10 hours. Okay, that's what that notation means there. So T is between 0 and 10. Okay, then we're going to find what the total cost is when the bike is rented for 4 hours, and if the total cost was $50, for how many hours was the bike rented? Okay, so let's start. First off, we need to write a rule. Okay, so with our rule, we have a fixed charge of $20. Okay, so the total cost, C, regardless of how often the bike is used, this fixed charge is our 20. Okay, and then we've got plus $5 per hour of use. So if we have 1 hour, 5. If we have 2, 10. If we have 3, 15. So depending on what t is, we have 5 times t. So simply put, we have 5t. Look, this is a. Okay, so to get this in the form c equals mx plus c, if you will, in this case c equals 5t plus 20. Okay, now next we want to do is b. Okay, is we want to sketch this graph, okay, of c versus t for between 0 and 10 hours. Okay, so now what's important here is to get what we know. Okay, so we know that our gradient is 5, okay, and our y-intercept is 20, okay? It's our initial amount. Okay, so we're going to start with that here. I'm just going to use in application problems, we just want to use the first quadrant, okay? Now, this next part is very important. We want to label our axes appropriately, okay? So our cost is dependent on what happens over time. So up here we have our cost in dollars, okay, so C. And down the bottom here we have T, so time. Alright, now initially, so this point here is our y-intercept, okay, so when T equals 0, our y-intercept is 20, okay, and it's going to increase at a rate of 5 to 1. So we're going to start here, and it's going to head in an upwards direction. So if we just start here, initially it cost $20, okay? Then from there, okay, because we're graphing from 0 to 10, here we need to make sure we have enough room to put 10 here. So this is going to be, you would use a ruler because it's important to do this accurately. So as long as they're roughly the same for me, 0, 5, 10, okay, we're going to use that information. Now, they give you this information so that we're going to use this time, so when t equals 10, this is called endpoints, okay, so t equals 0 is an endpoint and t equals 10 is an endpoint. So when t equals 10, using our rule, our cost is equal to 5 times 10 plus 20, which is equal to 70. So our total cost up here, let's see, 40, 60, 70. Okay, the highest we need to go is 70. Okay, so now, when t equals 10, cost equals 70. I'm going to use that to sketch my graph. Okay, so now, I'm just going to use a different colored pen so using a horizontal line from t equals 10. Okay, so approximately there. Okay, we have our endpoint of 10, 70. Okay, then our graph is going to be in a straight line from there, our initial position, to 70. Okay, 10, 70. Alright, so that's our graph. So use that endpoint, 0, 20, and 10, 70 to sketch your graph. Okay, and it goes in a straight line. My graph wasn't exactly straight there, but close enough. Okay. Alright, so for part C, we want to look at what is the total cost when a bike is rented for 4 hours. Okay, so using our graph, okay, we can get an approximate thing. So when t equals 4, okay, so we know that t equals 4 here. Okay, we can, using a straight line, trace it back to this point here, and maybe it's around about 40. Okay, this is 20 to hit here, maybe a bit less. But what we're going to do is use algebra, okay, to solve this problem, so it's a bit more accurate, or a lot more accurate. Okay, sketching is good for a reference, but algebra is going to give us the exact amount. So our function was c equals 5t plus the initial cost of 20. Okay, so if t equals 4, the total cost is going to be 5 times 4 plus 20, which is equal to $40. Okay, so Therefore, cost for 4 hours is $40. Okay, so always finish with a written answer, okay, for our questions. And yeah, next one for D. Okay, if the total cost was $50, for how many hours was a bike rented? Okay, so here we want to know what was T, given that cost equals 50. Okay, so approximately here is 50. Okay, it's using the graph, we would come across to here. Okay, then from there, make our way down. I'm just going to scroll down. Still getting used to this pen. Okay, so maybe 6 hours. Okay, but of course, we're going to do this using algebra just to be sure. Okay, so part D, cost equals 5t plus 20. Okay, now we know that our cost equals 50, so we substitute that in, so we get 50 equals 5t plus 20. Okay, and we're trying to find t, so we take 20 from both sides, so 30 equals 5t, therefore t equals 6. Okay. So that means that, therefore, the bike would be rented for 6 hours if the cost was $50. Okay, so finishing with that sentence again. So you can see graphically, okay, we can get a good picture, okay, if this was drawn accurately. But we also can use algebra and substitution to work out the cost. So the key here is to identify what it is you're trying to find. So in this last one, cost is 50. We're trying to find t. In this third one here, we were trying to find our cost. Okay, so c equals what? Okay, and using the endpoints to sketch your graph. So whatever this value is here, t equals 10. Okay, so t equals 10 here. Substitute that in, get the value so you know how high to go up on your vertical axes. Okay. Now I'm just going to start you off on this one because I just wanted to clarify one thing. Okay, so Marie's water can is initially filled. Okay, so that's going to be our y-intercept, and with 2 liters of water. However, the watering can has a small hole in the base and is leaking at a rate. Okay, so this is our gradient, but because it is leaking, okay, we're going to have a negative gradient. Okay, so we need to be careful of that. Okay, negative gradient. Okay, leaking 0.4 liters per minute. All right, so then just if it's a plus up here, okay, we add the gradient times by the number of hours. Here, 0.4 liters per minute, so we're going to have the 2 liter tank subtracting the 0.4 times the number of minutes t. Okay, so it's going to be a minus 0.4 t. Okay, so V equals 2 initial minus 0.4 t. Okay, so just look for the keyword there, leaking, or if it's adding, it's a plus. If it's leaking, it's a negative. Okay. So for your questions, okay, you can go ahead and do this one, but exercise 1F and questions 7 to 11. Okay, so underline the keywords, identify what you need to find, and sketch the graph. All right.